hello all. Welcome to the Day 3 Product Stability session for TAC 2020. My name is Rohini and I'll be hosting this session for you today. Very excited to have Yasub and Narasimha today as our distinguished speakers. Briefly introducing them, I'll go with Yasub first. Yasub is a technical agile coach and a great inspiration for teams, as people call it. He's worked as a developer on .NET technologies for over a decade and now leverages his agile experience and skills of clean code, extreme programming, pair programming to help teams in achieving their technical agility. His colleagues call him a pro in test-driven design, and teams are inspired by how he connects daily activities with agile values and Scrum events. He's been honored and awarded for a significant contribution and performance. He lives by the values of focus, openness, courage, commitment, and respect, showcasing professionalism. Welcome, Yasub. Glad to have you here.
Thanks.
Partnering with him, we have Narasimha Badrinath. Narasimha is an agile coach and DevOps consultant with over 14 years of experience in developing, architecting, and delivering software solutions. He has a very unique blend of coaching talent, technical expertise, and at the same time, very calm, composed, and approachable personality. Keeping software engineer practices at the heart of agile transformation, he has helped several teams set up effective continuous delivery pipelines and coach teams with extreme programming. The stage is all set for you guys. Welcome our participants too, and we appreciate your presence here today. Please post your questions and it will be taken at the end of the session. And the stage is all yours. Yasub, Narasimha, thank you once again. Yeah.
Thanks a lot, Rohini. I'm sharing my screen, just let me know when it is visible.
It's visible.
Right. Hi, everyone. That's elaborate introduction. Thank you so much, Rohini. So me and Yasub, so today we are going to talk about and also share our experiences about emergent architecture in this session. I am a developer and I have been a developer from almost 15 years now, and I love development. And as developers, many of us would have worked on multiple projects or products or even small applications. And in every developer's life, there will always be at least one project or product that they were part of where they would have learned a lot of things. And they'll be talking about that experience years later, giving those examples in like wherever they go in their current teams. Like I was in that particular project, I developed that application. It was like amazing. I spent nights and days to deliver that. So things like these. So even when I was a senior developer, only with a title, so in around 2008, long back, I know, but I also got this opportunity to work on a very important application. I was very excited about it because when I heard the requirements for the first time, it was so complex that neither myself or any of my colleagues had worked on such a difficult project so far. So generally, it is in our nature that we are drawn towards the complexity. We love to solve difficult and complex challenges. And I was no different. So naturally, I was thrilled to be part of this project. We started with understanding the requirements. And once it was over, the design phase started. The tech lead, myself, and another senior developer, we actually spent a lot of time. We spent several weeks to come up with the initial architecture, how the high-level design should be, even to the low-level design, the classes and the functions to that level, and even the database columns, what it has to be there before we start off with the development. After this is over, when the development started, so as expected, it was again a difficult time to implement all those things. Yet, we managed to pull it off, and it took a few months. But finally, when it was ready, we tested it, we asked everybody to test it in our teams, and then we went to the users who are actually going to do user acceptance testing. When we asked them to use the application, they used it, and in just a matter of few minutes, they came back and said, how can you expect us to use such a complex application? We cannot ask our users to use this. It's impossible. For us, it was like a shock. We were literally shocked, and we didn't even know what to say. So after some time and thought, they came back to us and they said that, okay, if you guys could simplify it by giving, let's say, only few of the necessary functionalities, so that our users can use it, is it possible? And guess what? It was very difficult to even remove the functionalities. So Yet we thought, okay, let's try to give it a shot, and we spent nights and days again for a couple of weeks, and then we provided what they asked for. They gave it to only few users, and then finally, a week later, they came back to us and said that we are really sorry, this is not working out. Let's scrap it. It was an effort of almost entire team for a year. We wanted to know what went wrong. We were all upset. We all met and asked that why this happened. There was one common answer. It was way too complex to build from the start itself. Why did we do that? We should have thought about it. So this was the sense. This was the answer from everybody. So this is my experience. And there was my first learning. We had started with highest complexity possible for that particular product. It was never about to become simple. The question was, would it have been different if we had started with our customers what they asked us to do in UAT phase? But I had no answer then. But today, after being a part of development of many products and coaching several development teams, I feel that the thought of emergent design is not when you start with your first line of code, or it's not when you're creating or coming up with an architecture or design for your application. So it's about starting small, no matter how big or complex or difficult the product is, or it will eventually become. But there is a lot more to it. Before we see that, let us have some fun. Okay, can you all see my screen? So I have just changed it. So
Yes.
there is a URL at the top. So menti.com. I request all of you to just visit this website, just in your mobile or a laptop, tablet, wherever. Just open a browser tab and put menti.com and use the code 254111. This is just a very simple fun activity. Just try to log in and wait for the question to appear. All right. I hope you are able to see the screen. Let's have some fun. It's the first slide. If you're there, then I'm moving to the first question. Check your browser tab. You should have got this question. How frequently architecture changes? There are a few good options. Never in a product's lifetime. Whenever new decision maker joins, with every on-site visit. So please provide your answers. As I said, so there's no right or wrong answers here. It is just for fun. Okay, I'm definitely having a good time to see the answers. All right, that was nice. Okay, let me quickly move on to the next question. Who takes architectural or design decisions? So again, no right or wrong answers. It's just for fun. The expert, or the one who knows a lot of jargons in the team, or many times there will be a design battle or POC or spikes battle. So whoever wins that. All right. Thank you so much for your participation. I think it was indeed fun to look at the answers. So I think I think for you also, I hope it was fun for you all as well. So probably some of them are actually true in many cases. Let's go back to okay. Uh, When I say architecture, so the architecture is the skeleton of the system, the structure of the system, the elements which are involved, their properties and how they are connected. And the design is the implementation detail. It is at the classes and functions at the code level and how they work together to provide a functionality. And in our experience, what we have realized is that having a design emergent helps to keep your architecture emergent to a great extent. So with this thought in mind, let's see that when every product development team takes an approach for their development, then let's see what are the types of approaches they can actually take and what happens in each of these approaches. The first approach, and this is the most common approach we have been seeing, this is the phased approach. It is, I don't want to talk much about it because this has been being used for a lot of decades. It's traditional waterfallish approach where everything happens in a stage. The next two approaches are more important for us. So the second one is Agile with BDUF. Why I'm saying is that because a lot of organizations are using this approach. So what happens in this approach is that the product development is done in an agile fashion. However, majority of the architecture or design is decided upfront. And the development of the features or the functionalities happens in iterations or sprints. That's agile with big design upfront, or we can call it as big upfront design as well. The third approach is the incremental architecture or design approach. It's an interesting approach here. Unlike the previous approach, as and when we progress in product development, the architecture and design is also changed and adjusted based on the requirements. Let's quickly look at what happens with Agile with BDUF approach at first. So here, if you see, we have a time frame where it starts with iteration 0. So here is where most of the pre-work is done before the actual development. Most of the times, the architecture, the design of the application is decided in this time frame. Many technical decisions are taken. What we have seen is that it might actually take from a couple of weeks to several months, depending on the size of the product. But of course, after that, the iteration will go back to 2 weeks or 3 weeks of like sprint or iteration. But iteration 0, there is no guarantee that you will actually finish in 2 weeks or something. It's a good enough buffer size. So in this case, after the development starts, features are delivered every iteration. And when we go further in time, team picks up the pace and it will be able to deliver more and more features. It reaches a time where they are actually they're at the peak of delivering features. One thing I want you all to notice here is that the architecture, the design, what they have come up with, I have put only the architecture diagram for now, but what they have come up with is not changed at all. From the time that they have created probably in the iteration 0, and it is not changed at all. It is iteration 5 for me now, but it would have gone till iteration 20 or 30. We don't know, but they have not changed it at all. So moreover, because of the business pressure, when the requirement starts coming in every iteration, it will be tried to fit into the existing architecture or design, which was created months ago or some years ago, possibly. We have even seen the instances of architecture diagrams created and not even touched or updated for years. Slowly, it will reach a point where the number of features they were able to deliver reduces. And after a few more iterations, it reduces further. What's happening here is that unknowingly or sometimes even knowingly, the architectural debt and the technical debt is accumulating. And when it becomes substantial, the team will reach a stage where they will not be able to take any more requests. Martin Fowler, in one of his talk, Agile Architectures, says that the architecture should be in the heads of developers. We have also provided that in the references slide of this presentation. So now, can you imagine asking developers to keep such a huge architecture in their mind when they start developing from the first day? So at least I have found answer to most of my questions in Agile. So let's look at the 10th principle of Agile Manifesto. And it is one of my favorite principles as well. Most of the times, when we look at this principle to apply, we will try to apply it on requirements. Many times the agile coaches, scrum masters, everybody, I think most of the times it is applied at the requirements. Out of so many requirements in front of us, how many of them adds maximum business value and we can start delivering them? And which of those that has lower business value and that can be pushed to the later stage? It's amazing principle, and that actually works all the time. Let's see how to apply this principle at the technical level. We have lots of technical decisions to make before the product starts off. Then which are those decisions that have the highest technical level and can be taken immediately? And which are those decisions that has less technical value and can be deferred to a later stage? Yes, just like how we use business value for requirements, we use technical value for the decisions here. But then, how do we know what kind of decisions that can be deferred? Let's take a look. There are lots. Basically, there are technical decisions are the very important aspects of product development. There are tons of technical decisions taken by development teams during product development. These could be from very high level as the choice of DB or the language to choose or the cloud service provider to even writing a very smallest if condition for a scenario in a story. And one such example could be the database design. Although we might think that the database design is a fundamental thing to an application, it is something that has to be completely thought through, designed and documented upfront. But is it? Should it be? Robert C. Martin, in his talk, Clean Architecture, even the reference for this is provided in the references slide. He talks about when creating a fitness framework, how they were able to defer using the database for almost a year. Like when they started, they probably felt the need, but they thought, okay, can we do without the database for now? Yes, they used the data structure and they were able to defer the database. And after some time as well, they thought, okay, probably we need the database now. And they again decided probably we can use hash tables, and they again deferred the decision. Like that, they were able to actually defer the choice of a database itself for almost a year. So not necessarily that this can be applied to all the applications, but can some of the tables, schemas, decisions, can that be deferred? I think it's a question worth asking. Like that, frameworks, libraries, I think many of the times we have seen that a lot of frameworks, libraries in our applications are used. Question is, can the decision of which framework or library to use, can it be deferred? Probably yes. Sometimes probably we can even defer it all the way till the story is picked up or to be delivered. And then we can think that, okay, which framework or library to be used for this particular story to be delivered. Low-level design. I really don't know how many teams are still doing this, but I personally feel test-driven development is an amazing practice. I would choose TDD any day over coming up with a low-level design for applications. And UI wireframes. Likewise, when you have an application where you have to create multiple web pages, you need to know exactly where the elements should be and things like that. So sometimes people create all of the UI wireframes up front and then they'll start using the development stages. But probably can we defer this all the way to the sprint or an iteration where the story is actually there to deliver? We will know only when we ask this question to ourselves. Is this needed now, or can we defer this? There are many such examples over, to take the technical decisions. We're not going to go through that, but just to give an example of how and what can be deferred and what may not be. Having known now to how to apply the simplicity principle and the kind of decisions that can be deferred, let's see a simple example of how incremental architecture design might look like. This is the third approach that we are talking about. If we are developing an application, when we start, although we have an entire product in front of us to build, we will focus only on those features that need to be delivered in the next few weeks. Probably we need a Git repository. And if it is a data intensive application, a database with just enough tables and schema for features to build. We might later in the stage, when we go through few iterations, we might need authentication and authorization. We will include that when we pick up those requirements. And after that, we realized that we need some way to store intermediate data or maybe some logs to debug. And so we probably can include logging and caching and etc. So on and so forth, the data analytics, the load balancing, the scaling, and whatever is required, when you need it, probably you can add it then. Here, what we are doing is that we are changing the way we think from the mindset that because we have this architecture and design, what features we can deliver in this particular iteration, to we need to deliver these features. So what is the minimum and architecture that we need? So we are just trying to reverse the order of thinking. Here, the overall approach looks, I think, really good. So I think probably looks like if you follow this approach, everything is great. So it still leaves us with one question. Is this approach enough? Can we say that this is emergent design? For that, let us go to Yasub and see that he has an answer for it.
Sure.
Yasub, over to you.
Thanks, Narsi. So let me start sharing my screen. So Narsi, do you see my screen?
I do, yeah.
Okay, thanks. Hey, thanks, Narsi. So Narsi spoke about 3 approaches and with more emphasis on incremental architecture design. But he ended up with a question that, is this enough for having the enough emergent architecture or design? The question is that, why did he leave with that question? Because let's have some more questions around that. Because now we are saying that a development team should take the decision at the time when it is really required. Now every developer might be taking the decision. Now the question is that every developer might have their different way of thinking, designing, and coding. So how do they align to the common design? Then the next question could be that if we started with a just enough code, like the Narsi said, that just enough architecture or just enough design, then how do we maintain or sustain the pace later on to build it that fast that we did it just with the just enough architecture, just enough code? The next question could be that if we are making so frequent changes to our design or to our system or to our code, how do you ensure that the existing system or existing functionality is not broken? And here is what we believe, that incremental architecture with having some technical practices or technical excellence can help you to have the emergent design or emergent architecture in place. So in short, you need to have the technical agility in place. And what we are saying is there in the manifesto for agile software development, and if we take a look at the principle, it clearly mentions that continuous attention to technical excellence and good design enhances the agility. So before we get to the next level, that let's try to understand that what are those practices that we have been using it for years now, and that we recommend to the teams that will help to come up as a emergent design or emergent architecture. So the very first one, test-driven development, my favorite. I have been using this for almost 10 years now. And for the first time, when in 2009, when I heard about test-driven development, I didn't understand what is this, and I didn't believe. Because as a developer, my first question was that how can you even write test before writing the production code? But once I started using it, there was no turning back. And I have countless examples from my experience that I can talk about where we started with a complex problem. We had no clue that how to draft a design. But as and when we start with a cycle of red, green, refactor, the design will start coming up automatically, and the end design will be so simple, scalable, and easy to test, and easy loosely coupled that we would have never imagined at the beginning of it. And let me give you another reference that we were listening to Neil Ford, another speaker, and he mentions in his talk that cyclomatic complexity of a code which is generated through TDD lies between 1.5 to 2, Whereas the code which is written without TDD, the cyclomatic complexity is between 8 to 15. So you can imagine the level of the complexity between the test-driven development code and the non-test-driven development code. Okay, so in test-driven development, we talk about red-green refactor, but at the refactor level, like, a lot of time question comes that what are the practices, what are the things that we should take care that, that makes our, or what is the basis based on which we should do refactoring. So clean code solid principles or the design principles that helps to come with the emergent architecture. Again, from my experience, I was working as a developer for one of the team or one of the product development, and our client made it mandatory for the whole team to read this book, Clean Code by Robert C. Martin. And in a week, we used to spend 3 to 4 hours as a team to learn more about clean code and solid principles, and that were really quite useful. Team reviews. Team reviews are different than the normal code reviews or offline reviews or peer reviews. Here, the whole team comes together and reviews the code. So again, let me give you an example from my working experience. So we used to have this 4:30 meeting every day, and we used to sit in team room or agile room or war room. There were different names at that time. We used to sit in a war room, and then what used to happen is that the person who has made a code change since last working day, he or she would showcase it the code on the big screen, the projector. But first, let me tell you, when this practice was introduced, nobody in my team, including myself, was comfortable, because none of us wanted to show our code on a larger screen that everybody is looking at it. So all the pair of eyes looking at the code same time, we were not comfortable. And initially, the reviews were on a very trivial practices, like, the questions were like, why have you named your field variable like that, and why is it not according to the coding standard? But slowly, when the whole team matured a little bit on those coding standards, the comments started coming at a design level. The questions were like, why your class is not designed that way, or why are you having the duplication, or why are you touching the framework code? So such kind of maturity that we achieved, and what it helped us was the whole team now was aligned towards a common way of coding and common way of designing the application. Continuous refactoring. I think we are talking about not refactoring which happens once in a week, once in a sprint, or once in a while. It's like part of your DNA. It's like you're breathing day in, day out. So you don't put conscious efforts in breathing. Rather, it's like just happening. Sometimes you breathe heavily, sometimes you do normal, but you're always breathing. And it's like, if you don't do continuous refactoring of your code, then it's like, developing serious diseases over the course of time, which you could have easily avoided if you were like having little or lightweight exercise on a daily basis. So that is what continuous refactoring we were talking about. Okay, so then acceptance test driven development. Now that we are talking about emergent architecture or emergent design, we are saying that, your design or the code should change, or your architecture should change on a very frequent basis. And at a unit level, you have written test-driven development, so that is making sure that all your units are working fine. But at a integration level, or at one level above unit test, how do you make sure that your system is still working fine with those frequent changes? Obviously, you could go with the traditional approach of having a automation test suite of automated system testing, automated component testing, integration testing, API testing, a lot of different type of test suite that you can talk about. But what we recommend is the test first approach, and acceptance test driven development is one of those which has been very prominent and useful in our experience. Okay, before I get into some more practices that we have in our list, let's have some more fun. So we would request you to go to menti.com and use the code 60H62. So again, there are no right answers, or there are no wrong answers. There are just some funny answers. Nasi, would you help me? I mean, is it visible?
Yes, it is visible, Yasub.
Okay. So I assume, and by the way, guys, the code has changed. The code is now 60H62. So let's get in there and just see some of the funny questions coming in there. So when or where do the best design ideas come from? Do they come from the Gang of Four design pattern books? Or so somebody says that when the project is over. Actually, I resonate. Over a coffee break. Okay. That's cool. That's fun. Okay. I think when I was designing this with Narsi was very excited about option number 2. And he said that he doesn't smoke, he doesn't go for a smoke, but still the best ideas come for
That's
a smoke
true.
at a smoke break. Okay, let's get into the next question. One more question we have. Who's responsible for creating a quality product? So the one who has written million lines of code, or who spends the weekends to fix bug, make sure that the quality of the product is maintained because he or she is fixing the maximum number of bugs, or the one who manages the whole team? Oh, we have a balance here. See, it's a tie between the one who manages the team and the one who fixes the bugs.
Yes.
Okay, cool. So that was some fun, guys. Let's come back and see what are the other practices that we are talking that has helped us in our experience. So tactros, or they are called technical retrospectives or tech retros. So again, from my experience, we used to have a meeting called design walkthroughs. So it was not actually called as tactros at that time when we were having. And Monday, Wednesday, and Friday, late evening India time, we used to have this meeting. And the purpose was that teams from all the three geographical locations come together and take a look at the development that has been done. And when I say development, it's not about the code reviews. It was more at the design level that, how exactly this feature team has developed this feature. Are they aligned towards the common design? Are we having any variations, or did we do something really new? What were the challenges that we were facing, and how did we solve those challenges? And the outcome of this was that all the feature stream were aligned together. In our case, it was very frequently because we were having a lot of feature teams working on one single product line. But for different teams, it could be similar to like a sprint retrospective, once in a sprint or twice in a sprint, wherein the facilitation could be same, but the purpose is not to look at the process side, but only at the technical side and look at the design side. Design refactoring. I just now spoke about continuous refactoring, and I'm talking about here about design refactoring. So this design refactoring is a little different than the continuous refactoring. Of course, in continuous refactoring, we talk about design refactoring, but their focus was more on code. So like, your function names, your class size, or your variable names. So that is more on the continuous refactoring part or the code refactoring. Here in the code design refactoring, we are talking at the design level. Once again, let me give you an example from my experience. We got a request that we had one of the utilities. It was a command line utility as part of one large product, and you can think of that utilities like dir command by page, or dir command by width, or by hidden files, or something like that. So there were multiple options, and we were requested to add 3 more options to that utility. When we started working on that code, we realized that it's becoming difficult to add those options. The code is not really scalable. So then we decided to get into a room and said that, let's take a look at the code. And I remember within 25 or 30 minutes, we came to conclusion saying that this code is not maintainable and we cannot extend this code. So we scrapped that whole code and we rewrote the entire utility, maintaining the old features of the functions and adding the new functions also. So here my intention is not to say that, every time when I say design refactoring, you're kind of rewriting the whole code. Rather, we are trying to say that whenever it is required, take decisions on refactoring your design. And sometimes it could be rewriting the components also, or sometimes it could be just improving that. Okay, this practice has been there. It's a very known practice, but unfortunately very less appreciated. But this is one of my favorite, and this I've been using for almost 10 years now. again. And I don't call it just pair programming, I call rather pairing, because according to me, you can pair not just to code. You could pair to understand the requirement. You could pair to design application. You can pair to have the test-driven development in place. You can pair to test the application, fix the bugs. Basically, wherever there is a complex problem, you could pair to solve that problem. And having this as a practice can help you a lot in having the emergent architecture or emergent design. Time box design discussions. This doesn't come directly under a technical practice category, but the reason it is here is because in my experience, what I have seen is that a lot of time teams, when they get into design discussions, they try to solve all the problem and they will try to cover all the scenarios within that one discussion. Let me again give you an example from my experience that once we were trying to work on a complex problem, and we had some constraints. The constraint were that we were not allowed to touch the framework code. I mean, if we were allowed, then I think that problem would have not been a complex problem. It would have become very simple. Now, without touching our framework code, we had to make changes and build some features. So me and my pairing partner, we got in front of the whiteboard and we started discussing. We had a couple of approaches in front of us. But then every time we take a look at the approach, we will see that, okay, there are a couple of problems which will not be solved by this approach. And we reached to a point where we said, okay, hell, enough of discussion. Let's put down our pen and get our system. So we got to our system and we said that, okay, we are going to do the text spike. So each of us took one of the approach and started working on that. By the end of the same day, we got the approach working. And the approach that worked was the least prominent in the morning. So we thought that that approach cannot work. By the way, that approach was to use reflection heavily. I know it doesn't sound very good technical decision to have, but trust me, at that moment, that was the best. And it was even accepted in our design walkthroughs, the tech through that I just spoke. So the whole product team accepted that as approach, saying that, yeah, that was the best approach to have it with the constraints we had. So the message is that, limit your time box, limit your discussion time, and just invest that time in your implementing the tech spikes or implementing the solution. Okay, all these technical practices are good to have your emergent architecture or emergent design. The question is that if you're not having a faster feedback or you're not having the pipeline set up, then all of these things, you never know what is working for you or what is not working or what is delivering value or what is not delivering. So the continuous delivery or continuous pipeline is really essential. Okay, now the question is that where do these, the architecture or the design emerges? Does it come from a single source, a single person, or a dedicated team? Well, I think the answer was manifested in 2001. It says the best architectures, requirements, and design emerges from the self-organized teams. So the design comes from the team and not from an individual. So let me very quickly conclude. Think big, start small. So you might think about a system, have a larger vision, but start small. I think Narsi spoke very well about that point. Defer decisions that won't impact current execution. Follow Yagni. You aren't going to need it principle. That comes from XP. So don't think about future, a lot about future. Don't code for future. Just do it, whatever is required right now. Just enough of architecture, just enough of design, just enough of code. Probably just enough shall be good enough. And last but the most important one, the technical excellence or technical practices are really, really essential for you to have the emergent architecture or the emergent design. Couple of places where we found really good people talking about really good stuff that you can visit and you just utilize. With that, we conclude. Thank you.
Thank you, Yasub and Narasimha. We have a couple of questions and I'll read out the questions for you. Okay, could you please repeat what you do in tech throws?
Tech throws. Okay, great. Thanks for asking that question. So tech throws are like similar to your sprint retrospectives. But in sprint retrospective, the focus is on almost all aspects: process, people, tool, technology, and everything. But in Tectros, the focus is mostly on your design or on your code or your technical aspects, that what is really going good from your design perspective. What are the challenges that you faced in this sprint or since last Tectro, and how did you solve that? Is it gonna was that the right decision? Are you hitting some technical debt? Do you need to solve the technical debt? Actually, technical debt is one very good thing that to look at in the tech retros. So in short, it is similar to sprint retrospective with complete focus on technical aspects.
Thank you, Yasub. The next question is, focus on the metrics for these engineering practices sometimes act as a disadvantage, and initially it slows down development. Have you experienced it, and how to overcome?
Okay, so see, metrics is a very wide spectrum, wide question. I'm not sure which metrics we are talking about. But if you ask me, I'm a technical person. I look at the technical debt as one of the metrics. A lot of things which comes from the Sonar Cube or static code analysis, I would consider them as metrics. But as very well said that, if we start focusing only on those metrics, then that becomes as a disadvantage and like kind of slows down. Yes, I agree to a certain extent. My focus would be that. Okay, let me very quickly share my experience that we hardly used to have such metrics in place. What we used to do was that our tech throws or design walkthroughs were the key indicators that how good are we doing in our technical space. So if the design the discussion is going in a direction saying that no, this is not working or this is not worth or I spent a lot of time, these used to be our metrics saying that something is wrong. We need to really work on that one. So it was not like a fancy or a beautiful this thing, but more of a discussion based.
Just to add one point to that, so I think we personally do not actually say use these matrices. So we say use the principles. The clean code principles and solid principles are the great principles. I think if you follow that, you might not even have to use your matrices. You will know that.
Yeah, thanks, Narasimha. The next question is, can you please come on fifth point again, which is after time box design discussion?
That's continuous delivery. It's as simple as that. You have a pipeline set up in place. So like, let's say we spoke about a lot of practices like test-driven development, ATDD, and we say that, you should have the automation suite in place or the static code analysis in place. But if all of these things are only in the development machine and they are not part of your pipeline and you're not delivering faster, then whatever the emergent design practices or decisions that you have taken, how do you know that whether they are adding value to your customer or not? So that is where we say that, continuous delivery is one good practice to have it to support all of this, to support all your emergent architecture practices. Narsi, did I miss anything?
No, I think it is true. I think deliver faster is only via having your continuous delivery. Otherwise, all of this is of no use.
Yeah, cool. So the next one is a simplicity principle. Please explain one more time, just at a high level.
Yeah, I think this is one of the very nicest principles that we have. So I think it is looked at like applied at the requirements level. Usually it is told to the product owners that if you have so many requirements, choose those requirements that which is adding maximum business value to you right now for this particular sprint, and move the rest of them to the backlog. So what we are trying to say is that apply this to the technical decisions. So when you start the product development, so before starting, you might have a lot of technical decisions to take. So apply this principle and see that, so what are those technical decisions that actually adds more technical value, and then apply or pick up only those decisions and take it today or probably in this particular sprint or iteration. So the rest of the technical decisions, if you think that these are having less technical value, push it, defer it to the next iterations.
Yeah. Thank you, Narasimha. In the interest of time, I'll take one more last question. How does emergent architecture and design is possible in legacy banning applications as ways of working different, and a lot of application depends on involvement in architecture and design?
Yeah.
Legacy applications?
Legacy applications. I was part of one legacy application. So we did another talk on it called technical debt. So basically it is tough. So the only thing is that the refactoring mindset is very important over there. So as Yasub said, so we don't look at it as a legacy application. We just look at it as any application where we are just working on every story. Every story should have a Boy Scout rule. So I leave the ground cleaner than before. And when I say that, so I'll make sure that we will follow all the principles and make sure that it is better than before. So when we slowly follow the approach for every story that we are working on the legacy application, so probably not in a month or 2 months, but in a year, definitely it won't be a legacy application for sure.
Yeah. Thank you so much, Yasub and Narasimha. It was a fantastic session for people who are talking about how emergent architecture should be used, and it will help you attain the technical agility. So it was a fantastic session. We look forward to more sessions from you guys. And participants, thanks a lot for being part on a Sunday evening today. Yeah. And please don't forget to respond to the polls that is currently being posted here. And there's one more session happening in 10 minutes. So we would appreciate if all of you can jump into that session. Thank you once again, guys. Be safe and have a great weekend. Bye-bye. And I'm closing the live streaming now. Thank you. Bye-bye.
Thanks to everybody.